In this video, we're going to start talking a little bit about schematic symbols. Okay, one of the things we want to talk about is the pictorials, which shows you the location of where things are in a system, and that's sort of what we're looking at now, minus all the lines. And we're also going to talk about ladder schematics. So for each of these schematics as we work through this, we are going to talk about both the pictorial and the ladder. Now, here we have a series of 5 components, okay? We have a thermostat, which is a cooling thermostat. We have a run capacitor. We have a start capacitor. We have a potential relay, and you can always tell this is a potential relay by pins 1, 2, and 5. We have a motor. It's a split phase motor. It has a start and a run winding. Your run winding will always have the lower resistance. So in this case, the start winding is 18 ohms. The run winding is 6. So when we put this all together, we have a capacitor start, capacitor run motor. So the type of motor here will be a CSCR. My run, okay, will be, so if I put this in here, we're just going to type in CSCR. My run winding resistance is 6. Okay, my start winding resistance is 18. So now what we need to do is we're tasked with connecting these different diagrams so that they actually come together and work properly. So since it isn't telling us what the voltage is, we're going to come into the thermostat with line voltage. Okay, and I'm just going to drag that over a little bit. Then I know that I have to, no matter what, out of the thermostat, I have to come over and I have to feed my run winding. Okay, so I might as well just come over for that first. We'll go ahead and take care of that. Okay, let me just put my lines in. And we're going to connect that all up. Okay, so I have to feed my run winding. I also know that I have to have a common, because every circuit has to have a common or neutral, L2 or whatever you want to call it. So let's go ahead before I forget and label this. We're just going to call this L1. I'm going to call this L2. Okay, now my run capacitor actually is connected between my start and my run winding. Okay, so my run capacitor is always in the circuit. So let's go ahead and take care of that first. Okay, so we'll take care of my run capacitor. Then my start capacitor, we're just going to pull this down to make this neat. Okay, gets connected to pin 1. Okay. And sorry about that, I'm a little bit OCD when it comes to lines. Pin 2 gets connected to my start winding. So let's connect pin 2 to my start winding. Pin 5 okay, gets connected to common. And we are going to go ahead and just draw a jump in here. Because I want to show very clearly that that line is not connecting. Okay, so what we have here is we now have a capacitor start, capacitor run motor. Now that's the pictorial. Now what we want to do is we want to take these same components and we want to turn these components into a ladder diagram. So I'm going to take a piece of, let's go ahead. We have room on the bottom here, so I'm just going to do this here. Okay, now I do have some pre-made up schematic symbols that I'm going to use as we go through this just to make this easier. But the first thing we need to do for our ladder diagram is let's go ahead and draw out my L1 and my L2 because it's a ladder. We have to have the side of the ladder done first. Okay, so we're going to do my L1, L2. Now, I need a start capacitor, a run capacitor, potential relay, and a CSCR motor. So I'm going to come ahead and grab my, as I said, I already have some of these symbols made up ahead of time just from prior. So I'm going to grab my CSCR motor. Just going to copy that. I'm going to go ahead and paste it in here. Drag it down to where I want it to be. So we have our motor over here. And now we need to go ahead and put in some of our components. So again, what we have at this point is everything over from the CSCR, okay? Because we have my run, my start, my run capacitor, my start capacitor. We have my potential relay down here at the bottom with its pins 1, 2, and 5, and you can actually now much better see how it's wired in the circuit. So let's go ahead and get our cooling thermostat. Okay, and again, cooling thermostat is always a close on temperature rise. So I'm going to copy that one over. And then we're going to go, I'm going to paste that in here. Okay, have that in there. Now I'm just going to go ahead and connect this together. Okay. So if we take a look at what we have now, we also don't want to forget to label TH. Okay, let's go ahead and put SC there. I'm going to put RC there. Potential relay. And let's just call this CSCR motor. Okay, so what we have now is we have a completed pictorial and a ladder diagram. It's important that we do both in order to see what we basically, so we can see order of operation much better in the ladder diagram, and we can find component location much better in the pictorial. So you do need to do both. So let's go ahead and we're going to go ahead and do number 5, which is the next one. Gets a little bit more complicated while we're at it. Okay, so this one is again, this is more representation of an air conditioning system. So we have a condenser fan, we have a compressor, we have an evaporator fan. My condenser fan is a shaded pole. We're going to wire our evaporator fan motor, which would be also the indoor blower motor, as a PSC because there's a run cap right there. And I'm going to wire the compressor as a CSIR, capacitor start induction run with a potential relay. Now, because of how this is all set up, I am actually going to use L2 or L1 as my common. So I'm going to go ahead and draw this one in first. Okay, we're going to use L1 as my common. I'm going to just bring it around here. And I'm going to bring it up there. Then I'll straighten this out for a minute here. Okay, I'm going to connect all my commons in, because if I don't, I might forget about it. So let's go ahead and get those connected in. Now we have one more common. We cannot forget about this potential relay. Pin 5 also needs to go to common. Okay, so we have now have pin 5. Okay, potential relay, pin 2 goes to start. We know our start winding is the 11. It has a higher resistance. Capacitor, okay, goes to pin 1. Run cap, okay, goes from, okay, we go to our start winding, and then we also, okay, go to our run winding. Now, as with most air conditioning systems, we're going to come into my thermostat. Okay, I'm going to come out of my thermostat. I'm just going to bring a, wire there, wire there, and a wire there. Now let me just, I'm going to, okay, it's not going to let me neaten that one up at all. So, okay, but that's basically what we look at, okay? Now that's a pictorial. Again, it shows you a wiring diagram. But again, with this sequence of operation, as they start to get more complicated, gets a little bit more difficult. So what do we have here? We have a condenser fan motor and a compressor. Oh, and I forgot the run there. Let's go ahead and get, I forgot one wire. Let's go ahead and get that run wire in real quick. Okay, we have a compressor and we have an evaporator fan. Compressor CSIR, evaporator fan is PSC, and my condenser fan is a shaded pole. So in the case of this one, we're going to go ahead and do our ladder diagram on a new diagram. So before I do anything, I'm going to go ahead and label this ladder for schematic AC5. Okay, now I'm going to go ahead and draw, well, let's draw my ladder first. Okay, I mean, granted, in this case, we don't have a lot of components, but let's not forget to draw the ladder. Never draw a line across the bottom, okay, because you will forget and you eventually will create a short circuit. So I'm going to create an L1, and then actually we're going to call this L2 to stay close to what we did on the other one. I'm going to call this L1, okay, because I wanted my common neutrals. Now, I have a CSIR on my, I have a PSC and I have a shaded pole. So let's go ahead, and I'm going to go ahead and start off by grabbing my shaded pole. I'm going to go back over here, paste that in. My shaded pole motor is going to be that's my condenser fan motor. Then I have a PSC motor. That becomes really, really easy. And you can draw all these little schematics and do your own little cheat sheet like I have here. As long as your instructor knows that you're doing it and doesn't, if you're in a classroom. I have my PSC motor. That's my indoor blower motor. Now all that I have left to grab is I want my capacitor start, induction run. We're going to use that. Actually, no, we need the one with the potential relay. So I'm going to go ahead and grab this one. And I'm going to grab it and put it over here. But now, because I need to remove one capacitor, okay, so I'm going to remove that run capacitor that's in there. Change the label of that. Throw a label here for PSC. And this was my evap. This is my compressor. And this is my condenser. Now we still have to put a thermostat in, right? So let's go ahead and put our thermostat in. It's a cooling thermostat like it always is in air conditioning. Pull it over here. Okay. So now all we have to do is put the components together. Okay, so I'm just going to take my line. Okay, and I'm going to do it rung by rung because you don't want to forget anything. Okay. So I have that. Then I'm going to come down from here. And I'm just going to connect my rungs in, right? Okay, so we have a cooling thermostat that's controlling a condenser fan motor that's a shaded pole. We have a capacitor start, induction run motor, and we have an evaporator fan. So again, what we've done is we have a ladder diagram that matches the pictorial. Now, some people like to read the pictorials, but as circuits gets more complex, you have to be able to go back to a ladder, because sooner or later we're going to start adding more and more safeties to these and other control devices and safety devices that you're going to need to be able to see, okay, the thermostat closes on a call for cool, what happens next? Because every one of these points where there's a junction is a point where you might want to be able to take a meter someday and go ahead and read a meter and figure out what's not happening, because everything is either open or closed or energized and not energized.